Hello, everybody. Can you all hear me well? Yeah. All right. Cool. I guess I will just dive on in, and you guys can quiz me about the iOS thing later. So what's this scale you speak of? So when you start out, super small scale, you got some front-end servers, maybe you got a database server, maybe that's just some file servers, maybe iBoxes, some batch processing. Your classic 2001 LAMP stack, wait, it's Ruby on Rails with Postgres now, or some other hipster thing that I don't know about. And your infrastructure is probably two boxes. That's our DNS, monitoring, graphing, deployment, assorted other random housekeeping things. Maybe you run your HR database on them too, because that's what you got. And this is kind of how everybody starts out in the very beginning for it. And I'm going to be really focusing on those two things with the air quotes of infrastructure tonight, because it's getting all that stuff to scale up right is how you get all of that other stuff to scale. So you move on to medium scale. Now you're kind of moving towards that service-oriented architecture. You said the LAMP stack was so 2001, and you decided that Ruby on Rails doesn't scale because it's hard or something. So you're like, hey, we're going to rewrite it all in Java, and we're going to do a bajillion services. So then you get to this point, and again, you have front ends and API hosts and database hosts, but you have them broken into different services. They talk between each other. Hey, maybe you even have like a read-only disaster recovery data center, which hopefully disaster never comes because you probably have to test it. I've been there, I've done this. It's just, hey, it's probably be fine. Nothing ever breaks, right? But now your infrastructure is getting bigger. All those little boxes are actually different servers. Maybe you've got a couple DNS servers. Maybe you've got some distribution of that. You got some back-end processing as well, so you're not having your business intelligence people do queries against your production database and taking down your site when they want to know how many sales you made or something like that. And then finally you get to large scale. Now you're globally distributed. You have full redundancy of data centers. The West Coast can completely fall off the map, and your site keeps humming along happily, even though you're super sad because you're on the West Coast. And then finally, you've got tons of hosts and you can sleep. And this is the point that we want to get to. But this is actually really hard to get to. So the first thing, state is the enemy. If I could write services that never had to have state, that didn't have to have databases, that didn't have to have files, didn't have to have any data, my life would be so easy, because state is really hard. So only do state when it matters. Absolutely focus. If you have some service and you want to keep some state about a session that's come in, so that you can be sure if the same person logs in again, you can cache the caching's fine, but you don't actually want to record any state on that box because it's something that you can lose. So anything that must get rights in a consistent state is going to be a single point of failure by definition. Magical, multi-master, multi-writer, globally unique ID consistency data source are trying to trick you. I am sure that Cassandra can magically do everything. I'm sure Mongo can magically do everything. So can React, and so can that thing that guy that who's really smart and did with MySQL will totally magically do it. But it's actually a really, really hard problem, which is why there's not a silver bullet solution for it. So that's why you want to minimize the cases where you're actually having to hold and record state. If data can be reproduced, it can be duplicated, so duplicate it all the time. So a blog post that somebody puts up is something you cannot reproduce, because somebody typed that in from their brain and did not make a copy of it somewhere because they're assuming that we're going to take care of that for them. So if it disappears, they're going to be super sad about it. But something, a feed that you get from some outside provider that you then munge into whatever right data format, that can be reproduced. Awesome, go duplicate that, put it everywhere, put it on tons of different things. Then if it blows up, everything's great, you're totally fine. Memcache is one of those things that people consider as a caching layer. It's performance optimization. Memcache is an awesome data store. It is totally a data store. It is not a data store that you want to have your data in that you need to get back later, but for reproducible data that you can reproduce from your database or from your file server or from whatever, Memcache is great for that. You shoot it in the head, it blows up, it's gone, who cares? I've got 20 more of them. But you actually have to treat it as a data store. Separating reads and writes. You have to do this. I have encountered tons of people who have built up applications, and they've either done one thing or one thing other. They've either, from the very beginning, were like, hey, cool, I got my Ruby on Rails, it connects to my backend database, I have one connection to my database, maybe I have a pool, but they're not thinking about read traffic versus write traffic. And then they get to the point where that one database that they've slammed Fusion IO drives into when they bought the biggest, most beefy server they possibly can, just won't scale anymore. And they need to separate out the read traffic. And they have no idea what they have to do for it. So if you're doing any development, any traffic that does not need to have instantly consistent reads based upon writes should go off on a different connection to your database or a different server in your file store and just be conceptually separated. Then when you actually need to scale that up, it's super, super easy. Because you're just like, okay, I'll just make another database or I'll make a memcache cluster because I don't care about that consistency. Let's talk about everything breaks, because everything breaks. So rates of failure. So if every host fails X% of the time, let's make that 0.00001%, and you have 10 million hosts, everything fails all the time. This is just the facts, like the statistics. It's totally provable. So if you're only n+1, then you have a failure that happens when you're doing maintenance, because of course you're not going to do maintenance on a live server that's serving production traffic, because that probably wouldn't go very well. You are going to go down, because you've taken your one bonus server down to do your maintenance on, and another one fails, and then you're totally screwed. So, rule of threes. Anything that's important has at least 3 servers. When you have tiny, tiny services, you move to that service-oriented architecture. It's, everything's really simple. I really need literally one box to serve 10,000 QPS because I rewrote it in Java and I'm awesome. You still need 3 of them because you need one that's live, one for maintenance, and one to go down. And then this also, unfortunately, includes data centers. So no matter how much money you're paying to your data center provider and how good they say they are, we've got our UPS, we've got our generators, we've got our secret flywheel generator, magic thing that's like a UPS but not even better. And then we've got power coming in from 6 different directions. Yeah, data centers still go down. So this is my favorite data center failure ever, aside from the data center that got struck by lightning twice, because that happens. So this squirrel, well not this squirrel specifically, but a squirrel, decided, this was actually in the South Bay, to chew through a power wire. And so it took out power. Unfortunately, it shorted in such a way that it blew out the UPS. And UPS is that thing that is in between your servers and the backup generator. So that went down, the whole data center was down. We had all this redundancy. Everything was built in, everything was going to be great. Freaking squirrel ended up taking out the whole data center. So, post-mortem action items, guy with a BB gun on the roof, and everything's fine. But this stuff happens, so you need to be prepared for it. And if you design all of your stuff to be ready for things to be failing all the time, and you just expect that's normal operating procedures, then you're in a good state for it. Also makes your life way easier if you're ever doing any sort of maintenance on anything. So when you're actually dealing with failover, you need to make it easy. This is another rule of 3s in its own way. If you can't do a failover at 3 a.m. while blackout drunk, it will not work when it is 2 in the afternoon and you are sober and have all of your best people live. Every single thing you do for failover, it should either be a script that can do it or a runbook that you literally copy and paste things into a terminal. The reason is when something breaks, you're going to freak out. Your adrenaline's going to spike, and you'll be like, I type as fast as I can, I'm going to make everything happen. And then you realize you're on the wrong box, you're on down, RF, everything, box is down, now you made the problem worse. This is just going to happen. And I've been both the guy that's had the 3 a.m. prepared for everything scenario, and I've also been the guy who freaked out and tried to do all the things that just made the problem worse. So you need to be able to just make this so incredibly easy that a failure happens and it's something that you expect, and you're like, okay, cool, so it failed. So I pressed the buttons and it failed over, and like, why are you bothering me? Everything's fine, don't worry about it, we'll fix that later. So let's talk about automation. So, automate all the things. Maybe, kind of. Well, yeah. So what do you actually want to automate? So you want to automate what makes sense to automate, which doesn't really kind of make sense. It kind of makes sense. Anything that's a repetitive task is great for automation. Anything that you do twice is not necessarily good for automation, because you're only going to do it twice. Anything you're doing all the time is a great task for automation. Don't automate decisions, though. Automate the process. Decisions are really, really hard to make. It is really hard to determine if a database has actually failed from the perspective of a bunch of different computers, or if your backend is corrupted. That's actually a really hard problem to solve. But you, as the big meat puppet computer, are really good at figuring that out, because you can have your brain subconsciously figure out all the different analytics and know what's the right thing to do in this situation. If we could automate all the decisions, then we would just automate all of our jobs away and everything would be fine, and slaves to the robot army, and then we wouldn't have anything to do. It's a really hard problem. So good automation. This script has a bug in it, so bonus points if you can find it, or a design flaw. Good automation is something that is easy to screw up by hand. So this is taking down an IP address on a host, or adding an IP address to a host and then sending out a gratuitous ARP. So if you needed to do IP takeover for something, let's say you're using databases and they do failover that way, this is the way you would do it. What's tricky about this is that you have to pass a net mask into your IP add or add command, you don't pass it to ARPing, and when you're doing this by hand, you will do it wrong every time, and then you have 30 seconds of downtime while you're trying to fail something over. This is a great thing that's good to automate, because it's something that's easy to screw up by hand, is a very repetitive task, and you can put into a script that will actually do it correctly for you and not screw up the syntax every time. This is scary automation. This is split-brain tolerant leader election with Paxos for single master replication. It totally can be done. There's entire things and people who have done research projects on how to have two masters that could both accept writes at the same time, but only send writes to one of them at a time to be sure that everything's totally fine. You really are not in a split-brain scenario so that you can fail over. But this is so hard to do. That's a lot more code. Can you find the bug in this one? There's a bug in this code. Anybody points it out, maybe? It's really hard to do. So you don't necessarily want to focus on doing that immediately. This is a hard problem to solve. And you can get paged, wake up, fix it in 2 minutes because you can make the decision of what the right thing is to do with all of your scripts that make this really easy, and then move on with it without having to worry about this going and freaking out and doing something horrible to you. So philosophically, when you're designing things for automation, you want to pretend that you're going to automate yourself out of a job. Pretend you're going to put that Paxos script into there that will make all the magic decisions for you, and instead have it be a prompt that says, should I do this, yes or no? Then don't do it. So don't ever do that until it's time to do it. So you get to that point where you build all your automation, and every single time you needed to fail something over, your alerting system has said, I have a guarantee that this thing is broken, we are not in this weird scenario, you've seen your network isolation happen to you, so you know it can't screw up, and you've had a human verify it every single time, and always made the right decision, then maybe you can turn it on in staging. And then eventually you get to the point where you can turn it on in production, and then you don't have to worry about that anymore, you can move on to doing something that's more interesting and more fun for you. So let's talk about managing assets. Yeah, we're going to get a little fancy here. No, not really. So if you don't know what you have, you can't manage it. So this is everybody's step one. You have an Excel spreadsheet. Maybe you're fancy and you've got a guy who loves DNS, and he's like, DNS text records are the future. I'm going to put MAC addresses and server locations, all that stuff in it. And this is where everybody starts off with it. So the important things for that, when even it is an Excel spreadsheet or DNS or something, is that you do have a source of truth. You need to have one source of truth for this data that is always accurate, or at least is the one source of truth you look at. And you want to distribute everywhere from it, and then you want to automate based upon it. So you always are looking at your central asset managed database. You could call it, whatever. You call it whatever you want, but this is what you always want to look at. And what's important is that you're going to get to the point where hosts are relevant. So remember, you have to have 3 of something in order for it to be something that you actually care about, because you need to have that level of redundancy. Therefore, an individual host is not particularly important to me, but knowing what services are. So even if you have a service that has only one host because of some silly reason that you didn't put it on 3 of them, you still want to make a service for that, because that's how you really want to interact with all of your systems. Because you're never going to have just like that one single box that's its special snowflake. And then everything should be discovered, validated, and reconfigured based upon the central asset tree. So don't rely on Excel, and you would need to build something for it. And there's companies that provide software that does this. I've never used them, but I'm sure there's great things out there where you could just like take some silly database and load up a schema and be done with it. Providing an API from your asset management, the reason you want to distribute it everywhere is then you can do really cool, interesting things with it. So I need to SSH into all 9,000 of my Dell R610s because they all have a firmware bug, and I need to see if they're vulnerable to this and will totally blow up. So I have a way that I can make SSH be like, okay, go out and go parallel, give me all the things of this specific class, and then go mess with them. It helps track down strange behavior as well. So, this service has been having issues, the network's broken, so you go to the network guy and you're like, the network's broken. They're like, no, the network's not broken. The network is never broken. Stop telling me the network's broken. And it turns out maybe you have a bug in your network card. But then you can isolate that all of these are the exact same model that you bought at the exact same time with the exact same Broadcom card in them and the exact same kernel on it. So, maybe there's a correlation here. Maybe it's actually that bug and not the network guy's router. Same thing with rate cards and all things like that. So you want to have a way where you're slicing and dicing your data and having it be as rich as you possibly can, and then have a way that you can actually interact with your hosts. Because having all that data is really useful, but if you can't automate logging into all of them and actually checking something, then you're still going to be back at the same amount of manual effort for it. Now let's talk about host names. So hosts change roles all the time. I am sure all of you have been in a case where the company that you're working for, everybody thought you had enough servers, and then you don't have enough servers. And so now the server that is called funnel cake, which makes no sense, is being used as the front-end web server for your main website. Or the thing that's called analytics is now your critical back-end database that if it goes down will take down everything. So hosts change their roles all the time. So we got into an interesting conversation about this at Square at one point. And one of the guys I worked with made the argument that hosts should not have meaningful host names. He wanted to call them A1, A2, A3. I thought that was a little bit extreme. So we kind of encoded the caliber of server, if it's like a web server class piece of gear or something else in it, and the data center it's actually in. But the important part of this is if you give it a meaningless host name, that forces people to interact with it by looking at your asset management database, looking at services and interacting with a service instead of a single host. And then people can't make one of those hosts a special snowflake because they can't remember what the heck it's called. And then when everything changes roles and you're totally out of capacity and that one thing's never being used, so you spin down 4 hosts over here, spin it back up over there, repurpose them, then you just kind of shift around how you have your things managed out for your services, and nobody really notices the difference. So let's talk about reproducibility. So configuration management. So why do we do configuration management? I've talked about snowflakes a lot. Snowflakes are bad. They're your special things that somebody duct taped together and you have no idea why it works that way. So we don't want those anymore, so we're going to use config management. Why do we need this? Servers break all the time. They need to be rebuilt. Again, if you have enough servers, something is always broken by definition. More traffic, you need more servers to scale. If it takes you 6 hours to build another web server and all of a sudden you're on the front page of Reddit, whatever, and you have tons and tons of traffic, yeah, 6 hours is not going to be enough time for you to spin up a bunch more boxes. And then there's, of course, if you can't reproduce it, it's doomed to be the one server you just can't turn off. I think pretty much every company has that one server that was back from the bad old days that was probably under someone's desk and then got brought into the data center and wired up and is this nasty tower that has dust and possibly fire shooting out of the back of it that cannot go down because if it does, then nobody will be able to log in production anymore. You don't want to have that, which is why you need to be able to reproduce things. So, how everybody starts config management? It's super simple. Don't worry, I'll get it set up right now. Everything's fine. This is the classic beginning part, which works when you have 3 servers and you never need to build another one, but also builds that magic server that has to go to the data center that was on the desktop. So you've got things, you've got Puppet, you've got Chef, you've got Ansible or the Fusion Reactor or whatever, and I'm sure there's other things out there. So you've got these tools that'll let you be able to do configuration management. So now that means, sweet, we don't have any more snowflakes anymore. I just slam all my roles into the Puppets. Puppets is magical, everything's great, now I can reproduce everything, and I don't ever have to worry about this again. So let's make me a snowflake. So these are Puppet roles. I'm picking on Puppet just because I've used it more than the other things. The majority of things that do config management potentially have issues like this. So originally, the top one is my original role where I said, let's put Apache on these boxes. Best web server ever. And then later, someone else comes along and they're like, dude, Apache's terrible. Why the heck are you using that? 1998 called. And they're like, let's put Nginx on. It's the best thing ever. So you delete the Apache is present rule, and you put in an Nginx equals present rule. So you built 2 servers. One of those is that really old server that had Apache. One of them is a server that you just built. What are they running? So one of those is running Nginx. One of those is running Nginx and is running Apache, because these are strictly additive rules. So now we've got a snowblower, which is super awesome, fresh powder. And this is a problem that you can get into. So the problem with a lot of config management is that it's applying rules, or it's applying Ruby scripts that run on your end hosts. And you don't necessarily have state that's being defined. But you can make these things generate state for you. You can make them build everything in your central place and be able to push that back out. You just have to be disciplined about it. You want to have state because then you are sure that a server is actually what you think it is. And you want to have a way that you can actually validate that. So you need to have rules for adding and removing things. What's easier to do than doing rule transitions, where you have to make sure that it removes the things correctly and then adds the next thing, and that doesn't cause any trickle downs or whatever, and you're not missing that secret RPM that something else pulled in when Yum ran and did sadness. There's just always replace everything. It's harder to get to this point, but if you can just re-image every single server anytime you need to upgrade or stamp out a golden master, your life is so much easier because you built one, and who cares if that one's a snowflake, because you're going to make 8,000 of them, and you have that central, very important golden master, and back it up on 7 different places so you don't lose it. That's the best way to do it. The other piece of this is always have history of any changes that you're making. Stick your stuff in Git. I know this isn't code when it's public rules. Well, it's kind of code. It almost parses like Ruby. But stick it in config management so you always know what the heck happens, so you're not surprised in the future. Let's talk about change management. Yeah, I'm going to get real agile on you guys now. So change management is not about bureaucracy. I hate bureaucratic process. I hate writing TPS reports. I hate having to get sign off from my managers and all of that stuff. But that's not what change management is about in the actual spirit of it. If you do the things I'm about to say for change management and never get an approval from anyone, you will still actually make your site stay up and run and go great. So first of all, you're already doing step 1 of it, which is that you are communicating. So you pop your head over the cue ball or across your wide open office space or whatever, and you go, hey dude, I'm going to drop all the indexes on the database. It's cool, right? Don't worry about it. I got to free up some space. We're going to run out of space, man. We're out of capacity. I'm just going to drop this stuff too. They're taking up like 50 gigs. Get rid of it. So the first part of it that's really important, the reason that you have to do change management is so that people know what you're doing, so that you're not surprised by it. And then the other part of it is knowing what you're doing before you're actually going to do it. So this has actually been proved to be the only part that's useful about config management. If you write something down and then go do it instead of just doing it based upon some vague notes of like, and then I fix the thing and then I do the stuff, you will break things less often. Passes the 3AM test, I could write a change plan at 11 in the morning that I'm going to be executing at midnight. I don't recommend doing this, but whatever. And then I go out to the bar at 6, drink till midnight, come home and be like, sweet dude, copy paste, copy paste, copy paste, everything's fine. And the reason this works is because then you can actually get things reviewed. You're not going to have typos when you're copy pasting things, unless you copy paste rocks, just don't do that. And then the other really, really big important part is the same thing as somebody popping their head over the wall that doesn't scale when you're in like 17 offices around the world, is knowing when stuff happened. The database is slow. Everything's broken. Well, what changed? Nothing changed. Are you sure? Did you deploy code? Well, yeah, we did, but that didn't change anything. Did your code like alter all of the schemas in the database at the same time? Yeah, they kind of did that. Well, maybe that was a change. Maybe this is the reason for it. Or, oh my God, nothing works anymore. Did the network team like go just update the firmware on the router at 2 in the afternoon? It's just important to have this as a piece of data. And this isn't about like, oh good, they got approved, so now I can yell at them and get in trouble. It's about knowing and isolating what has caused problems for you, because the majority of things that actually break, aside from just like a disk fails, is somebody changes something and it kind of goes sideways. So let me tell you a story about that. So I finally convinced someone that this is the right thing to do, because they were getting all uppity about there being this big change process, and they thought it was bureaucracy, and it was us becoming a big company. And they asked me, they were like, well, so we have to write up these change management things, and I have to get them approved. Well, can I write a script that spits out all the steps that I'm going to do? Because I don't want to write that 30 times. And I was like, yes, you should write a script that will spit out all the steps. Maybe your script could then do all the steps. And they're like, well, that was going to be step 2. And I was like, see, you've gotten it. Like, this is it. And then, like, your change is, I'm letting people know that I'm doing the thing that does the thing, and you know it's actually going to work successfully, and people know when you've done it.